Right, everyone. So lastly, we'll be talking about or basically the last groups of our homologous series. It's your carboxylic acid as well as the esters. These ones are almost similar, not similar, but there are many differences, and it's very, very important to know those differences. Right? You may be just confused in terms of knowing the structure when you are given the structure, because their structures may be a bit similar because they have slightly the same functional group, but it's just a matter of the position of that functional group, of which I'm going to outline the difference and make you aware on what to look at when differentiating or when looking at the structure to know if whether you are dealing with an acid or an ester. So the first thing that you need to know, if for instance you are given a name, this one will end with oic acid, right? This one will end with oic acid, while this one will end with OH. So an example here can be methanoic acid, while here you can have methanoate, right? Secondly, this one, the functional group here, the functional group is carboxyl group. Carboxyl group, and that carboxyl group is something like this. Fine, let's come here now on the other side. So here the functional group is an ester group, which will have something like this. Now I want us to look at this. These are very, very similar, very, very, very similar, but the only difference is that the carboxylic group is only found either at the basically at the first or in the beginning of the compound. So this one is usually found at the what? At the beginning of the compound. Beginning of the compound. But that ester group, you can have here, for instance, a hydrogen. It's still an ester group, right? It's still an ester group. But what is the difference, is that that oxygen, if you look here, this oxygen is attached to a hydrogen, which is basically ending, saying that, okay, it's basically beginning, but here it's starting from here, it's going forward. So this oxygen now is not at the beginning. So the single bonded oxygen is not at the what? At the beginning. So just pay attention to that. And another thing that you need to know here is that this structure, it's basically an acid. An ester is made up of a what? Of an acid plus an alcohol. I'm gonna talk about the esterification process on a separate session. Sure. Then let us now go to the general formula the general formula for carboxylic acid, it's CnH2n and 2O, right, or O2. And that also the general formula for an ester, it's CnH2n O2. So they have the same general formula, right? Meaning they will have the same molecular formula but different structural formula. And we regard to these as what? As functional isomers. But we're gonna talk of isomers, 3 types of isomers: your structural, your chain, your all types of isomers. We're gonna talk about them also on a separate video. Ne? So what else am I leaving here? So we talked about the suffix, an example. So let's just draw a structure of about maybe 3 compounds. So remember that the carboxylic acid is always at the beginning. You can, in fact, at the beginning. So 1, 2, 3. You can be here, it can be here. That would be the beginning. So for instance, if we put it here, it's going to be something like this. And when we call this, we can say 1, 2, 3, it's 3 carbons, right? So it's gonna be propanoic acid. It's gonna be propanoic acid. Let's draw an ester now with 3 carbons. Ne? So with this one, you may have something like this. Ne? And this one, when we name it, we're gonna say, again, the naming I'm gonna do with you guys on a very, very separate video. But if I were to name this one, I would call it, it's ethyl propanoate. This would be ethyl propanoate. Ne? So that's how you basically differentiate your carboxylic acid to an ester.